Please.
That was positive.
But then we came back and said, actually, dying isn't that bad.
Okay. So we are going to work with some trig integration basically the next 3 days. Today we're going to talk about regular old trig integrals. I'll give you some strategies. And then tomorrow and Monday we're going to do trig substitution. Yes. Trig substitution. You will need to watch the video.
Watch it right before your race.
I forgot to go over way back when Wednesday didn't I?
Didn't we also like not pick up on you? That really long. No.
Yeah, well, but we decided we all had the right answers. I just haven't passed them back down.
Okay. I don't remember that.
Okay, so we'll come back to that at the end of the period, okay? All right. Write these down. You need these.
Do you have to memorize these?
You will need these. So yeah. What do you notice about the second two? Well, first of all, the first one.
We know that one.
Okay.
We're going to have to regurgitate these.
Yes.
You will use them throughout many of these problems.
So, yes.
So we have to regurgitate all these.
That was awfully nice of
My
you.
sister said that accounting college was super easy and she got a bunch of extra credit. She had like 107. This is a college class.
My Calculus 3 instructor did not allow us to ever use a calculator.
Whoa.
Why can't we use like 4 functions?
Because they solve it for you.
4 function calculator?
Yeah. You have to add.
Okay,
Wait,
so do not write all of this down. But this is something, here are some strategies to help us with sine and cosine. Like this is what you're going to utilize, and this is in your book. But basically, I call this like the odd man out, okay? Odd man out. Much like Peter is today.
Code pumpkin eater.
Code pumpkin eater. Okay. So if you have an integral that has sine and cosine both, whichever power is the odd power, you're going to turn as many as you can into, you're going to have sine squareds. Okay, like, so this is like sine to an odd power. You're going to keep one sine as is. The rest you're going to turn into sine squareds so you can use the 1 minus cosine squared. Okay, so what that does is it leaves a sine left over for u substitution and everything else is in terms of cosine. Vice versa. If cosine has the odd power, you will leave 1 left over, change all of the rest to cosine squared, which then you can change to 1 minus sine squared, and you have the 1 cosine left over for the u substitution. Okay? Now, if both powers of sine and cosine are even, or you have just one of them represented in your integral and it's even, then that's when you have to use the 1/2 minus 1/2 cosine of 2x, 1/2 plus 1/2 cosine of 2x. Okay? I'm probably going to write those more as 1/2 minus 1/2 cosine 2x and 1/2 plus 1/2. Okay? Like break it apart. Okay. I am not teaching you anything new. I am reminding you of some things. The only way you are going to get good at these is if you
Practice.
okay. Okay, so who is the odd one besides us?
Sign.
Okay. So what we're going to do is we're going to leave one sign alone, and we're going to write sine squared. And what we can do is we can change the sine squared to 1 minus cosine. Okay, so we can do a couple things. We can go a couple ways. We can do the u substitution now, or we can break that apart into two separate terms and then do the u substitution.
Let's break it.
Just do it.
Just do it.
I can't say no to that. So u would equal cosine of x, which means du equals
Negative signs. Yes.
sine x dx. So we have negative the integral of 1 minus u squared times u to the 4th du. Isn't that nice? I think that's pretty nice. Because what we have is u to the 4th minus u to the 6th. There's our antiderivative. Question.
Was the other way the easier?
It's 6 one way, half dozen the other. Thank you for interpreting that. You guys have heard that expression before, right?
Yep.
Yeah.
I said that in a class and I had some kids who had no idea what I was talking about.
Just a bit for each one. Yep.
I thought baker's dozen meant it was more.
Yeah.
Baker's dozen means 13.
Yeah.
Because they make a third
That's what I
space,
said.
that way they can
I
use
said
it.
that.
I thought you said it was 1 less than 12.
No, one more.
That's why my shirt says French bread and baker's dozen.
Cosine.
That's what your shirt says French bread?
Yeah, I'm sure that says French bread, but always ask me what it means. And I don't know. I don't understand.
It's cosine.
Cosine is the odd man out.
Oh, boy.
So in this case,
Oops.
we're gonna write cosine squared squared because we have cosine to the 4th that we need to change, and then our 5th cosine we are going to leave unchanged. Okay, so we have sine to the 4th x times 1 minus sine squared, the quantity squared, times cosine of x dx. Okay, I think it's easier to do algebra with u's as opposed to sines. So I'm gonna go ahead and do voodoo right now. What are we gonna let u be? Sine. So du cosine x dx. Okay, here's our cosine x dx. So we literally have the integral of u to the fourth times 1 minus u squared du. Okay, now this is where it gets semi-tedious because we're going to have to multiply that out so we have a polynomial where we can use the power rule. Remember, anti-differentiation is not as flexible as differentiation. We have to actually get that all multiplied out. But
Let's do it.
we can do that in our head, right? 1 minus 2u squared plus u to the fourth.
Yeah.
So we have u to the fourth minus 2u to the sixth plus u to the eighth. Bam. Not so bad, right?
Not yet.
No. What's the catch? Okay, we have the situation where we have evens. And in that situation, what did I say we need to use? And what?
1 plus cosine squared cosine
Let's use it.
So 1/2 plus 1/2 cosine of 2x, the quantity. What? Hold on. That was right? No, it wasn't right.
That's cosine squared. Yeah.
That I didn't need to erase all of it. I had the formula right, but it means cosine squared. So I have to square that guy. Which, yes, means we have to do the distributing of the two binomials. So, what would we get? 1/4 plus 1/2 cosine 2x plus 1/4 cosine squared of 2x. Oh, heaven forbid. Can we take the antiderivative of cosine squared? Anytime you have an even power and only an even power, we have to use that formula. So what happens here?
We could just separate it, though.
We have to use the formula for this guy right here. So we have 1/4 times 1/2, well, I'll just write it, plus 1/2 cosine of 4x. We have to double the angle. When we apply that cosine squared formula, we have to double the angle. So we went from cosine of x to cosine of 2x, and then from 2x we have to go to 4x. If it were 3x, we'd go to 6x. If it were 10x, we'd go to 20x. We have to double it. Okay. So do you agree that this would be 1/8 plus 1/4 is 3/8? Whew, okay, you ready? Antiderivative of 3/8. 3/8 x plus the antiderivative of cosine is sine, but since there's a 2x inside, we have to account for the chain rule. So this was 1/4 sine of 2x. And over here, when we account for the chain rule, it would be 1/32 sine of 2x. And then we'd have to evaluate from 0 to pi over 2. Which,
We won't.
yep. Got on a roll. Okay. Well, let's think about this. We plug in pi over 2, and we get 3/8 times pi over 2. Plus, what's the sign of pi?
0.
Plus, what's the sign of 2 pi? Minus 0. Plus the sign of 0. Plus the sign of 0. 3 pi over 16 is what that is. I don't know, but the last 2 hours we've had marbles bouncing on our heads is what it sounds like.
They're probably running down the walls with centuries.
With what?
Centuries.
Probably. Probably. Well, if that's Miss Hylock's room, right? She's in the corner.
I think that class.
She's directly above us. On the corner.
Well, okay, so above us is Dr. Hylock.
Yeah.
Okay, and she's gone right now. There's They already went to stage.
From right here. Those kids running.
I thought the noise is coming up.
Austin's in that class that he knows there's.
Well,
If we hear it, it's probably Dr. Hylock's.
Can we go get them?
No.
Yes.
Get them.
Now we're going to work with secant and tangent. Okay? If we have secants and tangents together, we basically need to find a way for u substitution to work. Now here's the thing with secants and tangents. It's a lot more flexible than sines and cosines. Okay? But we know the derivative of secant is secant tangent, and we know the derivative of tangent is secant squared. Okay? So if there's a secant squared that we can leave out, we can use u substitution with tangent. If there's a secant tangent we can leave out, we can use u substitution with secant. Does that make sense? Okay. So their suggestion from the book is that if secant is even, you need to convert everything but 2 of them to tangents using the trig identity, the Pythagorean identity. And if tangent is odd, then save one of the tangents and convert everything else to secant. Now, both of those could happen simultaneously, so then we can be a little bit flexible. Okay? So basically, you just kind of need to figure out if secants and tangents are multiplied together in your integral. Can I leave out a secant squared, or can I leave out a secant tangent? That's what you need to think about. Okay? How many of you work?
well, I don't work contacts, I work in contacts.
Just one?
We're up options.
Alright, thank you. I'm just curious. Okay, so we have secants and tangents present. Talk with your neighbor. What kind of u substitution is going to work? Okay, what do you want to use u substitution with? What did you talk about? Nick, did you think of anything with your partner? You talk to yourself about it? What did you guys talk about?
It's all about like secant.
Like leaving out the secant tangent?
Yeah.
Okay,
And saying that either one would work.
either one would work. Okay. So either one would work. So let's go with your suggestion of the secant tangent. So,
Okay.
let me think about this here. You want to leave a secant 3x tangent 3x. We're just going to leave that off to the side, which means we have secant cubed of 3x and tangent squared of 3x. Which one are we changing? We have to change the tangent so everything can be in terms of secant. The derivative of the secant is the secant tangent. Okay, so we're going to change tangent squared to be 1 plus 1 minus. Nope. Secant squared minus 1. I'll get there.
So what is 1 with x is equal
Okay, so that's a good point. This formula works as long as the angles are consistent. So that can be a y, that could be a star, that could be 500 million. And as long as the angles are the same, the formula works.
Yes.
Okay? So we could let u equal secant of 3x, which means du equals 3 secant 3x tangent 3x dx. There's your secant 3x tangent 3x. So we have 1/3 integral of u cubed times u squared minus 1. Okay. Do you feel like I really taught you something completely new?
No, but we're not gonna
What? You're not going to get it.
Hey, shouldn't your U2 be
Yeah. Can't you tell that that's a 6?
the one above that?
This
And
one?
then it will be size.
When you multiply, you add.
Oh, never mind. I was thinking to
Any other? Okay, why do you think you're not going to get this?
because it's just,
There are a lot of
there's a lot of
rules.
rules, and you just don't know when to use them.
Okay. When do you use the changing the sines and cosines to the Pythagorean rule?
Odd man out.
Okay. When do you use the funky formula with 1/2 plus or minus 1/2 cosine of 2x? Okay, when they're all even.
What if they're all odd?
then you can pick sine or cosine to do the odd man out rule with.
Extra
Wait, the three formulas that we have to regurgitate, those are if they're all even? Like all the powers are even?
No, the first formula that I gave you was the Pythagorean,
Yeah.
and that's for odd man out.
But the other two?
The other two are for when you have even. Okay, what I'm gonna do is I'm gonna let you work on a couple problems, and then, with sufficient time, this time, we'll go over the way back Wednesday. I want you to do some homework problems, though.
See, it's the worst thing, because like, that's right here, you got to flip them over, and you can't see any of them, so then